Hi everyone, welcome back to another one of our videos. Today we're going to go through a Godolphin and Latymer school question, which starts off as a not too challenging question, but then we go into more challenging question afterwards. So it says here, Paya has three cards. Card A tells her to multiply by 5. Card B tells her to add 3, and card C tells her to divide by 2. Pia arranges her cards in order ABC and starts with the number 3. Her answer is 9. So she does 3 times 5 is 15. 15 add 3 is 18. Divided by 2 is 9. Okay, got it. Right, so it says if Pia keeps her cards in the same order and starts with 11, what is the answer? So we're going to do 11 times 5 is 55. Add 3 is 58. 58 divided by 2 is going to be 29. So 29 is going to be her answer when she starts off with 11. So that's that one done. What's the next question? It says, what whole number would she need to start off with to get an answer of 19? So if 19 here, because it's divided by 2, we're going to go in the opposite direction. So it's going to be not ABC, it's CBA. So we're going to actually work backwards, right? We're going to do inverse operation. So divided by 2 becomes multiplied by 2. 19 times 2 is 38. 38 add 3, or do subtract 3. 38 subtract 3 is going to be 35, and then instead of multiplying by 5, we're going to divide by 5. 35 divided by 5 is going to be 7. So she must have had 7 to begin with. Let's see if that works. 7 times 5 is 35, add 3 is 38. 38 divided by 2 is 19. Yes, it works. So when we're working with the actual outcome, and we're working backwards to find what was the input, we're going to do the inverse operation. So instead of divide, we multiply. Instead of add, subtract. Instead of multiplying, we divide. Question C, if Pia arranges her order CBA, now we're going to look at, first we're going to divide by 2, and then we're going to add 3, and then we're going to multiply by 5. So that's the new order, right? In, and you get something out. And she starts with the number 4. What is her answer? So it would be 4 divided by 2 is going to be 2. 2 add 3 is 5. 5 times 5 is 25. So her answer is 25. Now this last question is a bit more challenging. Okay, so let's have a really good think about this. If Pia changes the order of the cards, she starts with a whole number and ends with 15, which is also a whole number. Give all the possible orders in which she could have used the 3 cards. So let's have a rethink about the cards now. Card A was multiplying by 5. Card B was add 3, and card C was divide by 2. Now, if her answer, if she ends up with 15, then we got to really think about what could happen. So if she ends with 15, she starts with a whole number and ends with 15. Give all the possible orders in which she could have used her 3 cards. So if she ends with 15, she could, we're going to do the inverse. If it's ABC, we're going to do inverse, which is multiplied by 2, subtract 3, divide by 5. Okay, so if she ends with 15, we're going to do 15 times 2, which is 30. 30 take away, 30 add 3, sorry, is 33, and then divide by 5. That's not going to give us a whole number because it says she starts with a whole number. So this order ABC is not possible. In fact, yeah, ABC is not possible. Okay, so let's go and change things around. So let's see what happens if we can swap B and A around, right? So it becomes 15 times 2, which is going to be 15 times 2 is 30. 30, we're going to divide by 5 first, and then we're going to subtract 3. So 15 times 2 is 30. 30 divided by 5 is 6. 6 take away 3 is 3. Yes, right? So we can do BAC. BAC is correct. Okay, ABC is not possible. BAC is. What else is possible? Well, because we've got ABC, we might want to do ACB. Let's see if ACB is possible. ACB would be, what would be, if we've got 15, what would be the first thing we do? We're going to do the inverse, which is subtract 3, and then we're going to, is going to be C, so it's going to be times 2, and then we're going to divide by 5. Let's see if that works. 15 subtract 3 is 12. 12 times 2 is going to be 24, and can't divide by 5. So ACB doesn't work. Okay, ACB, sorry, I wrote it twice, doesn't work. Okay, so that's not possible. So let's go and kind of finalize this now. So we've got, what are actually all the options? A, B, C, A, C, B, B, A, C, B, C, A, and C, A, B, and C, B, A. These are all the possible outcomes. We've found out BAC doesn't work and ACB doesn't work. ABC doesn't work. And what was the other one? ABC doesn't work and ABC doesn't work and ACB doesn't work. Yes, right. So BAC does work. Tick. How about BCA? BCA. So let's get rid of this because it's confusing. BCA would be what? BCA would be, well, we've got 15 at the end. We're trying to work out what the initial number is. It has to be a whole number. BCA, A is divided by 5, so we can divide by 5, and then we can do times 2, and then we can subtract 3. So 15 divided by 5 is going to be 3. 3 times 2 is 6, and 6 take away 3 is 3. So BCA does work. So anything that starts with dividing by 5 is going to be possible because of the fact that 15 is divisible by 5, right? So anything that ends with A is possible, right? That's going to be possible. And so the only one we've got left is now CAB. CAB is the final one. CAB would be, what's C again? It's times 2. When multiplied by 2, A is divided by 5, and C is C is times 2. Let me do that again. Let me do that again. Let's go back again. So C, this is B. B is subtract 3. Subtract 3. Then we've got A. We've got B, which is subtract 3. Then we've got A, which is divided by 5. And then we've got multiplied by 2, which is C. So if you've got 15, subtract 3, which is possible, 12. But then divided by 5 is not going to give us a whole number. And so that's not going to give us an answer that we want. So therefore, CAB is not possible either, right? So we've got 1, 2, 3 possibilities here, and it says give all the possible orders in which she could be used all 3 cards. So BAC, BCA, and CBA are the ones that she can have a whole number answer. So hopefully that made sense. I took a bit more time with the last one. Wanted to be a bit more systematic and a bit more careful with what we're doing. And so hopefully that's made more sense to you, and you can answer similar questions like this, which is really working on number machines, but in a slightly different way.